In this problem, we are asked to express two numbers in scientific notation, one greater than 1 and one less than 1. Both expressions will be in the following form, where we will have a number called the coefficient, which also often includes a decimal point, multiplied by 10 raised to the appropriate exponent. To determine the appropriate numbers that go in each place in the expression, I first identify my first non-zero digit in my number, in this case 6. 6 will be placed in front of the decimal point, and all other non-zero digits in my number will follow the decimal point, 2 and 3. So 6.23 is my coefficient, and now I determine the proper exponent by deciding what I need to multiply 6.23 by in order to achieve 6,230,000. I do this by counting how many places I must move the decimal in my coefficient and in which direction to get back to my original number. Because my coefficient is less than my original number, I must move my decimal to the right. Each place the decimal in the coefficient is moved right equates to multiplying the coefficient by 10 raised to the first power, or 10. Therefore, if I move one place to the right, 6 in my 6.23, I get 62.3. 60.2.3 is like multiplying 6.23 times 10, or 10 raised to the first power. Moving the decimal place 2 places to the right gives me 623. This is like multiplying 6.23 times 10 squared, or 100. This isn't a game of guess and check, though, and so to figure out what I must multiply 6.23 by in my case, I'm going to go back up to my starting number. I'm going to place the decimal where it's found in the coefficient, then also identify where it's found in my original number. Because a decimal isn't in my original number, it's implied to be at the end of the final digit. And now I can see how many places my decimal needs to be moved right. So 1, 2, 3, 4, 5, 6 places to the right to go from 6.23 to 6,230,000. Therefore, it's like the same as multiplying 6.23 times 10 6 times, or 6.23 times 10 to the 6th power. Notice because my number was greater than 1, my exponent is positive. My second number is less than 1, however, it will be in the same form, and I'll approach it in the same way. I'll identify the first non-zero digit, 4, and 4 will be placed in front of the decimal. 8 is my only other non-zero digit and will follow my decimal. And now I'll determine the proper exponent by deciding what I need to multiply 4.8 by in order to achieve 0.0048. I again figure out how many places I must move the decimal in my coefficient, 4.8, to get back to 0.0048, and in which direction. Because 4.8 is greater than my original number, I will need to move my decimal point to the left. Each place the decimal is moved left equates to multiplying by 10 to the minus 1, or 0.1. For example, if I have 4.8 and I move the decimal point one place to the left, I get 0.48. This is the same as multiplying 4.8 times 10 to the minus 1. Let's go up to my number and see how many decimal places I need to move left in order to get 0.0048. So I'll first place the decimal where it's found in my coefficient, and then I'll count how many places I must move my decimal to the left. 1, 2, 3. Moving the decimal point 3 places to the left then is the same as multiplying 4.8 times 10 to the minus 1 3 times. It's the same as multiplying 4.8 times 10 to the negative third power. This is my answer, and notice in my answer, because the number 0.0048 is less than 1, my exponent is negative.